Hi everyone, hope you all are good. So, we're going to start with grade 9 maths. So, you can find all the lectures on all the topics on aplusstudents.com. You have to log in there using your sorry, using your email address and password provided by the administrator. Then you have to select math from the subject tab. Then you have to scroll down to grade 9 maths, and we're working on chapter that is statistics. And we're going to start with a topic that is interpret a scatter plot. So please make sure you have your notebook and pencil so that you can note down important points on your notebook. Got it? So let's start with interpret a scatter plot. So let's start with the scatter plot. Okay, so basically what are the scatter plots? You can note down the definition. A scatter plot uses dot to represent values for two different numeric variables. So the scatter plot looks like this. Here you have x and here you have y. These are the different points on the scattered plots. Got it? So we can make a best fit line in scatter plot to see what data is. We can make a line where where most of the points are we kn- we can see most of the points in a line. We can make a line to see this is the best fit. You can say this is the best fit uh, line, because if it covers more than 4 5 points under the line, then it is the best fit line. Got it? Because you need to see the patterns in the x and y values. Got it? Okay, let's start with an example. Grade 9 statistics. High enclosed. Okay, interpret a scatter plot. Okay, sorry. Okay, let's start with, does the scatter plot show a positive trend, a negative trend, or no trend? Okay, so we have to look at the scatter plot. We need to see what is the increase. If we need to see basically uh, what is the relationship between x and y values. Got it? So see here the x values are increasing and y values are also increasing. Got it? When the x values are increasing and y values are all also increasing, that means the graph has a positive trend. Got it? Okay, just look at the scatter plot. As x increases, y tends to increase because the x values and y values, both of them are increasing. That means um, y tends to increase. That means the graph is a positive trend. So draw the line that best fit the data. Notice that the line has a positive slope. Got it? Because the x values are increasing and y values are also increasing. So just make a line that covers most of the points on the line. This is the best fit line that covers 1, 2, 3, 4, 5, 6 points under the line. Got it? This one, 1, 2, 3, 4, 5, 5 points. So that is the best fit line. Got it? So that means the graph, the scatter plot shows a positive trend because as increase in x value, y values are also increasing. Got it? Okay. So draw the scatter plot, show a positive trend, a negative trend, or no trend. Okay, here the values of x are x increases, the y values are decrease. The y trend tends to decrease. So x values are increasing, but y values are decreasing. When x is 1, y has a maximum value here. When x is 2, then here you have y. See, when x is 10, the y value is here 4. That means the increase in x causes a decrease in y. Got it? That means it's a negative trend. Make a best fit line that covers most of the data. Here you have, and this line shows a negative slope. Got it? Because y values are decreasing. So it shows a negative slope. Got it? So it would be then negative trend. Got it? Okay. Does the scatter plot shows a positive trend? Yes, as x increasing, the y values are also increasing. Got it? Here you have x is 10, 100, y values are increasing. Got it? It starts from 10 and increase to 60. That means it's a positive trend. Got it? So just make a best fit line. Here is the best fit line that covers most of the points and that shows the slope is positive. Got it? Let's start with the test. Yes, if no change, if the values change in x and no change in x and no change in y, that means the values are, that is no trend. If only y value increases and x does not increases neither degree, yes, that means there is no trend, not neither positive nor negative, no trend. Got it? Okay, does the scatter plot show a positive trend, a negative trend, or no trend? See, as x is increasing, the y values are also increasing. Got it? You started from here. So as x values are increasing, the y values are also increasing. That means the graph shows a positive trend. Got it? Lost, you got your point? Okay. Does the scatter plot show a positive trend? Uh, that y values started from here and then decreasing. Change when increasing the x, y values are decreasing. Got it? That means it is a negative trend. Okay, good. So a positive trend, a negative trend, or no trend. Do you know the answer? see the y values are decreasing. Look at here, the y values are at maximum when x is just below 1. The y values are 9, but when x is 10, the y values are less than 4. Got it? That means it shows a negative trend. Change in x causes decrease in y, so it would be negative trend. Got it? Yes, very good in class. It is negative. Okay. Does the scatter plot show a positive trend, a negative trend, or no trend? It shows a positive trend because when x is increasing, y values are also increasing, so it shows a positive trend. Got it? Does the scatter plot show a positive trend, a negative trend, or no trend? It is positive trend. Increasing x changes y also, so it is a positive trend. Got it? Okay, so you can, okay, just look at this. Does the scatter plot shows a positive trend, a negative, or no trend? Here you have no trend. Got it? Because sometimes x is increasing and sometimes they are decreasing for y, so it is no trend. Okay, let's just move on to the very good. Let's just move on to the next topic. You can complete the test by yourself later today. If you need more help with the topic, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. Got it? Let's start with the next topic. The next topic is match correlation coefficient to scatter plot. Okay, let me write down the lesson name, then we'll start with the example. Match a correlation coefficient to scatter plots. Okay, let's start with examples. Let's start with examples. Okay, match each correlation coefficient to the appropriate scatter plot. The line in each scatter plot is the least square regression. Okay, so here for the first one, increase in x, the as the When the x values are increasing, the y values are decreasing. Got it? For the first one, that means it equal 2 equals 1. Got it? Because x is increasing and y is decreasing, so that means 2 equals 1. Got it? And for the second one, as x is increasing, y is also increasing, so it equals 1 equal to. Got it? Okay, for the one you have x is increasing, y is decreasing. Got it? When x is increasing and y is decreasing, the correlation coefficient is 2 equals 1. Got it? And when change increasing x is increases, y is also increasing, then it would be 1 equals 2. Got it? Let's see another example. Okay, so look here, x is increasing, y is decreasing. That means that equals 2 equals 1. For the one, the graph that has x is increasing but y is decreasing has a correlation coefficient 2 equal 1. Got it? But for the one where x increases and y also increases, equals 1 equals 2. Got it? For this one, you have 2 equal 1, and for this one, you have 1 equal 2. Got it? Let's start with the test questions. Okay, match each correlation coefficient to the appropriate scatter plot. The line in each scatter plot is the least square regression line. Okay, so for the first one, for the second one, the y value, the x increase in x values are increasing but y values are decreasing in the second graph. But for the first one, you have no trend. So it would be 2 equals 1 and 1 equals 2. Got it? Okay, match each correlation coefficient to the appropriate scatter plot. The line in each scatter plot is the least square regression line. Okay, so for the first one, x value increases, the y values are also increasing. And for the second one, when x values are decreasing, y values are also, x values are increasing and y value is decreasing. It would be 2 equals 1 and sorry, it would be 2 equals 1 and 1 equals 2. Okay, match each correlation coefficient to the appropriate scatter plot. The line in each scatter plot is the least square regression line. Okay, in the first one, when x values are increasing, the y values are decreasing. And for the second one, when x values are increasing, y values are also increasing. It would be 2 equals 1 and 1 equals 2. Got it? So here, change in x causes the change in y. That means it is 2 equals 1 and 1 equals 2. Got it? So for here in both the graphs, change in x causes a change in y. So it would be 2 equals 1 and 1 equals 2. Got it? So select the correct option and click on the OK button. Okay, so you can complete the test by yourself later today. Let me just move on to the next topic. The next one is quartiles. Let's start with the let's start with the quartiles, and let's start with example. In the data set show below, what are the lower quartiles, the median, and the upper quartile? So the data given is 26, 30, 35, 40, 42, 50, 51, 54, 79, 87, and 97. Okay, so we have to find the um, lower quartile, median, and upper quartile. Okay, so first of all, we have to find the median in the data. Median is the one that is exactly the middle number of the data. Got it? So they are arranged from least to greatest. Just count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. That means it's the sixth one. Yes, and here you have five numbers: 1, 2, 3, 4, 5. And here you have five numbers. Got it? So the median here is 50. Okay, so here the lower half is this one: 26, 30, 35, 40, and 42. This is the lower half, and this is the upper half. Got it? So in the lower half, 26, 30, 35, 40, and 42. The middle number is 35. The median is 35, or you can say the middle is 35. That means the lower quartile is 35. And here in the upper half, 79 is the middle number. You can say it is the upper quartile. Got it? So that means the median is the number in the middle when the numbers are arranged from least to greatest. The lower quartile is the median of the lower half of the data, and upper quartile is the median of the higher half of the data. Got it? So let's start with another example. The data is 1, 2, 4, 4, 5, 6, 8. You have to find the upper quartile in the data. So the data is also arranged from least to greatest. Just find the middle one. So you have 1, 2, 3, 4, 5, 6, 7. They are exactly 7. So this one is the median. Got it? You have to find the upper quartile. So the upper half is this one, and in the upper quartile, the middle one is the upper quartile. Got it? You can say this is the upper half, and in the upper half, the upper quartile, that is the middle number is 6. Got it? Okay, let's start with the test. In the data below, what is the lower quartile? The data is 2, 2, 3, 4, 4, triple 6, 7, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you have the all of them are they are just 10 numbers, so you can divide them easily into two groups. This is the one of them is this one and one of them is this one. Got it? You have to find the lower quartile, I think. Yes, so lower quartile, this is the lower half. So which number is exactly the middle number in the lower half? 3. Got it? So 3 is the lower quartile. Got it? This is the lower quartile. So the correct option is 3. So select the correct option and click on the OK button. Okay, in the data set given below, what is the lower quartile? The numbers are 21, 51, 67, 73, 82, and 89. 1, 2, 3, 4, 5, 6. So that means you can divide the data into two exactly equal groups and you have to find the lower quartile. So the lower quartile in the lower half, the middle number is 51. That is the lower quartile. Got it? So select the correct option. 51 is the lower quartile and then click on the OK button. Okay, the next one is in the data set below. What is the upper quartile? The data set is 1, 2, 4, 4, 5, 5, 6, 8. No, just 1, 5, 5, 6, 8. Okay, so we have to find the uh, quartiles in the data. So for the quartiles in the data, you have 1, 2, 3, 4, 5, 6, 7. 7 in number, so exactly the middle one is this one is the median of the data. This is the lower half, this is the upper half. Now just look at the middle number of the lower half. The lower half is this one, and here the middle is 2. That means the lower quartile is 2. Got it? So the 2 is the lower quartile. Got it? Select the correct option and click on the, oh sorry, not, we have to find the upper quartile. So the upper quartile is 6. Got it? So select the correct option and click on the OK button. Okay, the next one is in the data set below, what is the lower quartile? 15, 21, 21, 26, 36, 51, and 54. 1, 2, 3, 4, 5, 6, 7. That means the fourth one is exactly the median. So 36 is the median. Got it? 26, sorry. 26 is the median of the data. Got it? Now you have to find the lower quartile. Lower in the lower quartile is the middle number that is in the exactly in the lower half. So 21 is the lower quartile. Got it? Then for the upper quartile, here you have in the upper half, the middle number is 51. That is the upper quartile. Got it? So the correct option is 21, 6, 26, and 51. So select the correct option and click on the OK button. Okay, then given next one is in the given data set below. What is the upper quartile? Okay, you have to find the upper quartile: 19, 21, 45, 49, 50, 51, and 56. 1, 2, 3, 4. They are exactly 7. That means the fourth one is the median. Got it? You have to find, I think, the lower quartile. Sorry, upper quartile. So this is the upper half, and in the upper half you have 51. This is the upper quartile. Got it? So you can complete the test by yourself later today. Let me just move on to the next topic. Okay, the next topic is mean absolute deviation. Mean absolute deviation. Let's start with examples. The data set given below, what is the mean absolute deviation? Okay, the data set is 17, 44, 92, 91, 60, 50, and 52. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Yes, you have to find the mean absolute deviation. So first of all, we have to find the mean of the data. Got it? So at step one, you have to find the mean of the data. So for the mean, we have to add them all, and they are 7 in number. So you have to divide them by 7. Got it? Just add them, and we have to divide it by 7. So it would be then 406 over 7, and that equals 58. That means the mean in the data is 58. Compute the mean absolute deviation. Okay, just subtract the mean out of all the numbers. Got it? And then add them. Like start from 17. 17 minus 58. Then 44 minus 58. Subtract the mean value from all the given data. Got it? Then 92 minus 58. Then 91 minus 58. Then 60 minus 58. Then 50 minus 58, and plus 52 minus 58. Just solve them all and add them. Got it? So let me write down the values. Okay, 17 minus 58 is negative 41, but you have to calculate the absolute value, so it would be positive. Got it? 44 minus 58, again negative 14, but you have to calculate the absolute value, so it would be 14. Got it? 92 minus 58 is 34. 91 minus 58 is 34. 60 minus 58 is 2. 50 minus 58 is absolute value of 8, negative 8 is 8. And then 52 minus 56 is negative 6, and the absolute value is 6. Got it? Just add them all and divide them by 7. 41 plus 14 plus 34 plus 34 plus 8 plus 6. It would be 134. Sorry, it is 138 over 7, and it would be 19.1. So we have to round to the nearest 10, then it would be 19.7. To the nearest 10th, the mean absolute value definition is 19.1. Got it? The mean absolute deviation is a measure of how much a data set varies. Got it? Let's start with another example. The data set given below is 9, 5, 8, 3, 7, 1. Okay, so first find the mean of the data. Just add them all and divide 9 plus 5 plus 8 plus 3 plus 7 plus 1 over 6. Got it? So the sum of the number is 33 over 6. 33 over 6, and that equals 5.5. Got it? Now subtract the 5.5 from every value. 9 minus 5.5 plus 5 minus 5.5 plus 8 minus 5.5 plus 3 minus 5.5. That's why we have to calculate the absolute values. Got it? 1 minus 5.5. Got it? Now let's just subtract them and add them. 9 minus 5.5. It is 3.5 plus 5 minus 5.5 is 0.5 plus 8 minus 5.5 is 2.5. 3 minus 5.5 is 2.5. 2.5 absolute value makes it positive. And then for the last one, 1 minus 5.5 is 4 over zero point 0.5. Got it? Just add all the values and it would be 15, and 15 over 6 is 2.5. The mean absolute deviation is 4.5, 2.5 of the question. Got it? Okay, on the top right corner, we have a test button. Let's start with the test. Okay, 15, 21, 82, 59, 86. We have to find the mean absolute deviation. Calculate the mean. 15 plus 21 plus 82 plus 59 plus 86 and divide them all by 1, 2, 3, 4, 5 because they are 5 in numbers. Got it? So let's just calculate the 15 plus 22 plus 82 plus 59 and plus 86. It would be 264 over 5. 264 over 5 is 52.8. That means the mean is 52.8. Now just subtract the mean from all the values that are given in the data. Got it? And add them. 15 minus 52.8 plus 21 minus 52.8 plus 82 minus 52.8 plus 59 minus 52.8 plus 86 minus 52.8. Got it? Just subtract all the values. So 15 minus 52.8 is 37.8 plus 21 minus 52.8 is 31.8. Then 82 minus 52.8 is 29.2. Then plus 150 plus 59 minus 52.8, it would be 6.2, and then plus 86 minus 52.8, it would be 33.2. Got it? Just add them. 37.8 plus 31.8, 29.2, 6.2, 33.2. It is 138.2 and divide them by 5. 27.64. That means the mean absolute deviation is MAD is 27.64. Got it? So the correct option is 27.7. So correct, select the correct option and click on the OK button. Let's just do next question. They are a bit long, but they are very easy. Got it? You just have to calculate mean. Then you have to subtract all the mean from all the values, and then you have to add them. Okay, for mean, just add them. 5 plus 8 plus 2 plus 6 and plus 6 over 5. Just add them. 5 plus 8 plus 2 plus 6 plus 6. It would be 27 over 5. So it would be 5.4. Now subtract 5.4 from all the values and add them. 5 minus 5.4, 8 minus 5.4, 2 minus 5.4, 6 minus 5.4, and 6 minus 5.4. Got it? Just subtract them. 5 minus 5.4 is negative 0.4, but it's an absolute value, so it would be positive. So 8 minus 5.4, 2.6 plus 2 minus 5.4, 3.4. Then 6 minus 5.4 is 0.6 and 0.6. Just add them. 0.4 plus 2.6 plus 3.4 plus 0.6 plus 0.6. So it would be 7.6 and divided by 5. So 7.6 divided by 5 is 1.52. That means mean absolute deviation is 1.52. Got it? Select the correct option and click on the OK button. Okay, so you can complete the test by yourself later today. If you need more help with the topic, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. Got it? So we have done 4 of the topics. They are interpret a scatter plot, match correlation coefficient to scatter plots, quartiles, and mean absolute deviation. Got it? So if you need more help with the topic, you can contact any tutor on Skype. They are available from Monday to Friday, 5 to 9. Got it? That's all for today. See you in the next session. Bye.